Hey guys, and welcome to this video on determining whether a relation represents a function. So, let's get it on. Alright, before we dive right into looking at some relationships and determining whether they're functions, let's quickly recall the definition of a function. Remember that a function is a mapping, rule, or relationship between values in which every input has exactly one output. If there's any input that has more than one output, then the relation is not a function. So let's look at three examples of relations represented by tables of values, which I have named Ernest, Carl, and Mike. Alright, let's take a second or two to look at these three and determine whether or not they're functions. Starting with Ernest. Let's see, is there ever a time when one input has more than one output? That doesn't seem to happen at all, so we'll say that yes, Ernest is a function. Alright, let's look at Carl. Now, Carl seems to be a pretty interesting relationship. Every single input has the exact same output. No matter what the input is, the output always is 1. Is this going to be a function? Well, since it's never the case that a single input has multiple outputs, then yes, Carl is a function. Alright, let's look at Mike. Is there ever an instance where one input has multiple outputs? Well, I'm looking at this very first row, and it appears to me that the input 2 has an output of 3 and an output of 5. Note that that's a comma and not a decimal. So in this case, we would say that no, Mike, the relationship Mike is not a function because the input of 2 has outputs of both 3 and 5. Note that it's really important. If you're going to say that something is not a function, you want to say why as well. So one dead giveaway when looking at a table of values that your relationship does not represent a function is if in the same row, for the same input, you have two outputs separated by a comma. Then you immediately know you are not looking at a function. Now it very well could have been the case that we'd have two separate rows, each having the input 2. So one row with 2 having an output of 3, and another row with 2 having an output of 5. That would be the other way to determine that you are looking at something that is not a function. Alright, let's look at these exact same three relations, this time represented with mapping diagrams. Now, when you're looking at a mapping diagram, as long as you don't have multiple arrows coming out of the same input going to different outputs, then you're fine. Then you've got a function. If you ever have a case where you have two or more arrows coming from the same input and going to different outputs, then you know you're not looking at a function. So let's start with Ernest. Ernest, looking good. Every single input has exactly one arrow going to exactly one output. Ernest is a function. Alright, now let's concentrate on Carl. Again, Carl's a very interesting looking relation. All of the inputs go to one output, namely 1. But we see that every input has exactly one arrow coming from it. Therefore, Carl is a function. Alright, let's turn our attention to Mike. If we zoom in on Mike, we can immediately see that the input 2 has two separate arrows coming from it, going to two different outputs. Therefore, we immediately say that Mike is not a function because the input 2 has multiple outputs, namely 3 and 5. Always want to be very specific as to why something is not a function. Here are two more relations represented with mapping diagrams, just to show that we don't even need to know the numbers in order to determine whether this relation is a function or not. All we need to do is look at the inputs and see if we ever have two arrows coming from it. So immediately we see that this relation on the left is not a function because this input has two outputs coming from it, and we immediately see that the relation on the right is a function because each input has exactly one arrow coming from it. Okay, let's look at our original three relations again, this time represented as ordered pairs. Now I'll tell you, for me, this is the most difficult representation to use to determine whether you're looking at a function. But either way, we're going to learn how to use it. Okay, let's zoom in on Ernest. So, all we need to make sure is that it's not the case that two different ordered pairs have the same input with different outputs. So the same first number with different second numbers. So let's look at all the inputs. We have 2, negative 1.4, 0, negative 12, and 17. Since none of those inputs are ever repeated, we know we're looking good. This is a function. It's totally okay that the output of negative 3 is repeated twice. That's totally fine. If it were an input, it would be a different story. So yes, Ernest is a function. All right, let's take a look at Carl. Again, Carl's a pretty odd looking relation because every single input gets mapped to the exact same output. We see an output of 1, 1, 1, 1, and 1. But that's not what's important. We need to look at our inputs and see if any of them have multiple outputs coming from it. So we see 2, negative 1.4, 0, negative 12, and 17. No repeated inputs. Impossible that any input could be mapped to two different outputs. We're looking good. Yes, Carl is a function. All right, let's take a look at Mike. So let's look at our inputs and see if any of them are repeated. So I see 2, negative 1.4, 0, negative 12, 17, oh, and 2 again. So I see 2 as an input up here, and I see 2 as an input down here. And note that they have different outputs, 3 and 5. So immediately we say, this relation has a single input with multiple outputs. Mike does not represent a function. And again, we're going to want to be very explicit as to why, because the input 2 has multiple outputs, namely 3 and 5. Okay, time for some practice. So here are 6 different relations that I would like you to determine whether or not each is a function. So please pause the video now and determine whether each of these 6 are functions or not. And when you're done, please play the video and we'll reconvene. Okay, looking at the first function in the upper left, it looks like every input has exactly one arrow going to exactly one output. So yes, that first relation is a function. Looking at our middle mapping diagram on top, I see that the single input 5 has 1, 2, 3, 4, 5 different outputs coming from it. This guy is so far from being a function. No way, not a function. In the upper right, we don't have any numbers to work with here, but I'm looking at my inputs and every single input has exactly one arrow coming from it. That means every input has exactly one output. Yes, we are looking at a function. Looking at the relation Sophia, let's look at the inputs. We see that we have an input of 2 with an output of 3, and that same input of 2 has an output of 8. So immediately we see that we are not looking at a function. Sophia is not a function. Now let's look at Emily. I'm looking at my inputs of 3, 8, 5, 12, 24, and 0. No repeated inputs. It's impossible that this guy is not going to be a function. Emily is indeed a function. Note that it's totally fine that Emily has 2 as an output on multiple occasions. That's going to be okay. And note to self, Emily and Sophia are the exact same values, just the inputs and outputs have been reversed. So something to keep in mind. Emily is a function. Let's look at Rachel. Okay. I'm looking at our inputs, 7, 1, 2, 6, negative 4, and 1. Aha! I see that 1 is an input twice, having 2 different outputs. So we'd say immediately, no, Rachel is not a function because the input 1 has multiple outputs. Note that that is the only part of that relation that makes it not a function. It's totally okay that we have a whole lot of values showing up in different places. These are the only 2 ordered pairs that present an issue for us. Alright, let's investigate some real-world relationships where we're going to be told an input and an output, and let's determine whether the relationship is indeed a function. Okay, so for our first example, let's suppose that the input to this relationship was your age in years, and the output was your height in inches. Now the question we have to ask ourselves is it ever possible to have one input with multiple outputs? Is it ever possible to have the same age in years, but different height in inches? What do you think? Well, I think it's possible for you to grow in the same year. When you're 8 years old, you might be 5 feet, but you also might grow to 5 feet 2 inches in that same year. So we would say that this is not a function. There are some ages that are associated with multiple heights. All right, let's look at another. Suppose the input was the day of the year, and the output was the high temperature of that day. Well, let's think. Is it possible to have a single day with multiple high temperatures? No, of course, the high temperature of the day is the high temperature of the day. So this is a function, because for any day, there can be only one high temperature. The high couldn't be 72 and 76. No, the high would just be 76 in that case. Let's think about the inverse of that. And the inverse happens when you swap the input and output for relation. So what if we called the input the high temperature for a day, and the output would be the day of the year? Is it possible to have a single high temperature, but have that be the high temperature for multiple days of the year? Absolutely. A high temperature of 76 could happen in March and maybe in September again. So, since it's possible to have one input with multiple outputs, we would say no, this relation is not going to be a function. It's possible to have a single high temperature that was the high temperature for multiple days. Okay, let's look at another. What if the input was a car registered in New York City, and the output was that car's license plate number? The question we have to ask ourselves is it possible to have a single car with multiple license plates? Of course not. Every car has exactly one license plate. So this relation is going to be a function. Every input, every car has exactly one output, one license plate. All right, again, let's consider the inverse of that relation. And remember, the inverse happens when we just swap the input and output. So what if the input was a New York City license plate number, and the output was a car registered in New York City? Is it possible that one license plate number could be on two different cars? No, it couldn't be. Every single license plate number goes with exactly one car. So every input has exactly one output. This is a function as well. So we see in this case, in both directions, we had a function, because every car has exactly one license plate, and every license plate has exactly one car. It's kind of a one-to-one relationship, if you will. All right, a few more. Suppose the input was a person, and the output was that person's email address. What do you think? Is this going to be a function or not? I think it's possible to have multiple email addresses. I've got my personal email, and I've got my work email. So one person, it's possible that they could have two email addresses. One input could have two outputs. Not going to be a function. Now let's just think off the top of our heads about the inverse of that, where the input would be an email address and the output would be a person. Is it the case that each email address is associated with just one person? Typically, I would say yes. I think that inverse relationship would be a function. Every email address goes with exactly one person. Now, I know on occasion sometimes families have a family email address, so in that case it wouldn't be. But for the most part, I think that an email address is usually associated with exactly one person. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.